in this video, we are doing an intro to literal equations. So wait, numbers are going to start disappearing from our equations, and we're literally, literal equations, we're literally about to be solving equations with just letters. But we're going to take some baby steps into it first, okay? So we have two pre-examples. Just to remember our inverse operations, we're going to do 2x plus 8 is equal to 20. Okay, so let's draw the barrier around my equal sign, or the wall, the river, whatever you want to compare it to, whatever. Okay, and then we also, we have to do the inverse of PEMDAS. So we're going to first do the opposite of adding or subtracting. So in this video, I see a plus 8. So we're just going to subtract 8 on both sides. 8 minus 8 cancel, and we are left with 2x. And then 20 minus 8 is 12. And so from here, we're going to divide by 2 on each side. And we get x is equal to 6. Okay, that was pretty easy. We're good. Okay, we remember. The next one that we are going to ease our way into is 5x minus 2 is equal to 3x plus 4. Okay, variables on both sides. No big deal. We solved these before. We got this. Okay, pick a variable and solve it, or pick a constant which does not have a variable and not solve it. And move it from one side to the other. And I know I have to start moving things from one side to the other because 5x and negative 2 are not like terms. 3x and positive 4 are not like terms. So now we need to start switching sides. Okay, so I want to add the 2 to the 4 because I don't want to have to subtract 4 from 2. 2 from 4. 4 from 2. So let's do the opposite of subtract 2. Let's add 2 to both sides. Okay, when we do so, we get negative 2, positive 2 cancel. So we have 5x. Then we have 3x plus 6. Okay. Now we need to get the x pieces together. So negative 3x, negative 3x. And again, I'm doing negative because it's opposite of positive, or this is positive. We're going to subtract it over. 3x minus 3x cancels. So I'm left with 2x is equal to 6. And then final step, this is multiplication. The opposite of that is dividing. X is equal to 3. Okay, so we good there. Miss Anne's, why are you making it easy? Just hold up. Okay, so we have eased our way in. We remembered inverse operations. So let's just take one more look at what the inverse operations are. So if you want to draw a little chart in your notebook somewhere. Okay, we have the operations of addition, subtraction, multiplication, and then division. Okay, then we have the inverse operations. Opposite of adding is to subtract. Opposite of subtract is to add. Opposite of multiply is divide. Opposite of divide is to multiply. Okay, we just need to do this brief refresher, brief reminder. It needs to be there so we can see it as we start our very first literal equation problem. Okay, y'all ready? So here we have our inverse operations, literal equation problem number 1. D is equal to R times T. Okay, numbers are gone. And then really this equation is a mathematical equation or formula. And all it's saying is distance is equal to rate times time. Okay, and we're going to solve for, so it always tells you a variable or a letter to solve for. We're going to solve for R. Okay, same concept applies. Put a wall or a barrier around your equal sign. And let's remember some things. There's a reason why I put our inverse operations up here. So even though there are no numbers, there are still operations holding, I guess that's a good word we can say, holding our variables or our letters together. So yes, there's an equal sign. We put our barrier here. What operation is holding, if you want to think of it that way, the R and the T together? That operation is multiplying. So in order to isolate or get R by itself, I need to undo do the opposite, inverse my r times t. Okay, so that's why we wrote what is the opposite of multiplying? It's dividing. So I'm going to divide this side of my equation by t and this side of my equation by t. Okay, same concept with numbers. Letters, they cancel as well. T over t simplifies. Okay, so you are only left with r. Now, here's the funny or great thing, I guess, about literal equations. You cannot, like, just as if this was like a 2 and a t, or a 3 and a t, or a t and a 3, whatever. Okay, these are not like terms. They are not the same letter. So with that being said, and also one's capital, one's lowercase, we'll get to that later. Okay, these are not in the same format. They are not identical. They are not like terms. So we leave it literally, what's literal equations? Jeez, let me stop with that word. We leave it as d divided by, or d over t is equal to r. And I've solved my problem. That was it. I isolated, I solved for r. I got r by itself. And I can't simplify these any further, so I just leave it as d over t. I'm done. Not too bad, right? Okay, let's look at another one. Okay, literal equation, problem number 2. Okay, I have P is equal to I R T. Okay, and this is a mathematical formula out there for principal equals interest times rate times time. We don't need to know all of that. But we're also going to solve this one for R as well. Okay, so before we freak out, put the barrier around the equal sign, and then let's look at what operations we have. Well, what is holding, because we're solving for R, we're trying to get R by itself. What is holding I and T to R? Multiplication is. So what is the opposite of multiplying? Dividing. So we are going to do the operation of dividing to undo this on both sides. Okay, and we want to isolate, or we want to solve for R. So let me start putting a box around R, or the variable that we want to isolate. Okay, so we're going to leave R there, and then the operation that's holding the I and the T there is multiplying, yes. So the opposite of that is dividing. So we're going to divide by I and T. Divide by I and T, and they cancel on this side. Not to like terms at all on this side, so all you do is rewrite P divided by I over T, and that is equal to R. You have solved your literal equation. You are done with that one. Okay, just about done, just about finished. Okay, I need to flip my page over to the back, so I'm gonna be writing on the back of page 14. Okay, and we have two more actually. Okay, so number 3, we have x plus b equal to c, and we want to solve for x. Okay, so draw your wall or your barrier under equal sign. Okay, we're gonna isolate or solve for x. And we gotta think, what is holding the x and b together? That operation is addition, so we need to do the opposite of that. So opposite of adding is subtracting. So we're going to remove b from each side. And there we are left with x. These are not like terms. We cannot combine them. So we're literally just going to write back down c minus b. And we're done. We have x by itself, and we're going to subtract c minus b. We cannot combine these. These are not like terms. We're finished. Okay, one last one, number 4. X plus y is equal to z. In this case, we're going to solve for y. Y is the variable that I need to isolate in this case. Draw your barrier around the equal sign. Okay. So I need to get y by itself. Let's take a look at this x. This x is positive. What is the opposite of positive? Subtracting, or a negative. So we're going to subtract x on both sides. X minus x is 0. That part doesn't change. So we are left with this positive y, which is what we wanted to solve for. So we've already isolated the variable. And then these two are non-like terms, not alike, not the same, cannot be combined. So we just write down z minus x again, and we're done. Okay, so this was just an intro to literal equations today. They're going to get more tricky, but again, don't freak out. It's the same concept as if there were numbers, we're just solving for letters this time. And then this time it's even more unique because basically you just write down what you did again because you cannot simplify these any further. But you are still going to be isolating for the variable that is asking you to, and you're still doing your inverse operations, which is why we wrote them on the front page. So again, if you're watching this video during the 2020-2021 school year, you're making sure that you're taking notes with me for your notebook check. We are writing on page 14, Intro to Literal Equations, and then your independent practice work is going to be on page 15, where you're going to show your work and upload a picture for me. Best of luck to you guys with your intro to solving literal equations.